Hello, today we're going to study the box plot or the Box and Whiskers plot. It's known by both names. So for the first thing we're going to do is we're going to learn how to draw them. Remember that the box plot is something that you see that looks like this. That's why this ones are the whiskers. That's why it's called the Box and Whiskers plot too. You might also see it in a vertical fashion. So you might see it this way. It doesn't matter. It's the same plot. Okay. So let's look at how to draw this plot. So imagine we have a series of data, and they want us to draw the Box and Whiskers plot. So the first thing that we need to know is what each bar represents in a Box and Whiskers plot. So let's draw one very quickly. Okay, so this might be a typical Box and Whiskers plot. So the first thing you must know is that this line over here represents the median. Okay, remember that the median is the number that leaves the same number of data to the right and to the left. It's the center data if you order it from smaller to greater. Okay. So this box over here represents the first quartile, and this box over here represents the third quartile. Remember that the first quartile is the number that once you've divided the numbers with the median, you have an upper half and a lower half and an upper half. The first quartile is the number, it's like the median of the lower half, and the third quartile is like the median of the upper half. Okay? And then this is the minimum value, and this is the highest value. Okay? So imagine we have those values over there, and we want to draw the Box and Whiskers plot. So the first thing that we need to do is find these values. Okay, so we've got several ways to do it. We can, as we've only got 15 numbers here, we can order them from smallest to highest, lowest to highest, and find the median and the quartiles there. If not, we could just use the formulas for the median and the quartiles. We've got videos for that. So let's order the numbers in this case. So if you order those numbers, you have 14, 16, 17, 18, 18, 19, 21, 21, 22, 25, 31, 33, 36, 39, and 41. Let's check. We have to have 15 values. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's correct. Okay. So I've got my ordered values here. Let's look at which value is the median. It's an odd number of values, so we have to divide 15 into 2, and that's 7.5, and get the next highest number, so that's the eighth. The eighth value is going to be our median, so 1, 2, 3, 4, 5, 6, 7, 8. So 21, this one, is going to be our median. And let's check. We have to have 1, 2, 3, 4, 5, 6, 7 values to the left, 1, 2, 3, 4, 5, 6, 7 values to the right. So that's correct. So this is our median. Okay. Obviously, this is our minimum, our lowest value, minimum value, and this is its highest value. Okay, and let's look at our quartiles. So we have a lower half here from 14 to 21. 1, 2, 3, 4, 5, 6, 7 values. Again, an odd number. 7 divided by 2 is 3.5, so we get the fourth one. 1, 2, 3, 4. Okay, so 18 is going to be our first quartile. And 1, 2, 3, 4, 33 is going to be a third quartile. Okay, so now we have enough values to start representing our box and whiskers plot. Okay, so let's go to another page. I'm going to write the values. So our median was 21. Our first quartile was 18. Our minimum value was 14. Our third quartile was 33, and our highest value was 41. Okay, so let's use let's plot here an axis, and we have to have values from 14 to 41, and that's it. Okay, so imagine we would draw the rest of the graph to the right or to the left. Okay, and let's draw our box and whisker plot. Okay, so first of all, let's do our box quartile. Lower quartile is 18, so we'll draw our box there in 18. Our third quartile is 33, so our box is gonna end here. We can close our box like this. Okay, next thing, the whiskers. So our highest value is 41, which is here. And so we can draw our whisker there. Our lowest value is 14, which is here. Yep. And now we have to draw our median. So median is 21, and that is we can draw that there. Okay, so this would be our box plot or our box and whiskers plot for the data that we've just received. Okay, so what information can we obtain from a box and whiskers plot? We can get a lot of data just by looking at the plot. Things that we can find. First of all, they might ask us for our range. Remember that the range is the difference between the highest and the lowest value that we have. So that would be 41 minus 14, 27. So they might also ask us for the interquartile range. So the interquartile range is very easy. It's the difference between the third quartile and the first one. So that's 33 minus 18. Okay, so that's 15. And now, from the shape of the box, what can we obtain? Okay, so there's various things that we can obtain. If our box is small, it means that the data is not dispersed. It's very concentrated near some points. If our data is big, or if our box is big, it means that the data is dispersed along a big number, a big range of data. Okay, so we can obtain an idea of the dispersion or compare two box plots and find the difference between the dispersion in the data of each plot. The next thing that we can obtain is the skewness, if it's skewed or not. Okay, so a box can be right skewed if the right part of the box is bigger than the left part. Or in other words, if our median goes is near the first quartile, is near the left side than the right. Okay, so this one would be positively skewed. Okay, in the case where we have that the median is nearer the right side, so the left side is bigger, this is negatively skewed. Okay, in a positively skewed box plot, the mean is bigger than the median. In a negatively skewed, the mean is here on the left side, is lower than the median. Okay, in a positively skewed chart, it means that the frequency is higher, or there's more frequency of values on the higher range, and in a negatively skewed, there's more frequency on the lower range. Okay, we might have also an even non-skewed box chart where we have the same percentage on the right or on the left. As you see, the one on our exercise was positively skewed. There's more values here, more frequency of values here on the right, on the highest numbers of values than on the left. Okay, as you can see from 20 onwards, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 values out of the 15. Okay, so that's why it's positively skewed. Okay, other exercises that we might get, we might already, instead of being asked to draw the chart, we might get a chart and have to interpret. Okay, so for example, we have these two box charts, box plots, and we are asked to these questions. Okay, write down the time by which 50% of the so the time is on the x-axis, by which 50% of the ESK club runners had completed the run. Okay, so we know that the median represents the 50%. Okay, so answer for the question A would be 45 minutes. Write down the time by which 75% of the IRT club runners have completed the run. 75% is the third quartile. Okay, first quartile is 25, median is 50, third quartile is 75. Okay, so this would be 60 minutes. Explain what is meant by the cross on the ESK club box plot. It means some data that does not follow the trend. Okay, that's completely out of range. Okay, compare and contrast these two box plots. Well, as you can see, IRT is evenly skewed. The ASK is positively skewed, so there's more on the more values on the right, on the top part. So the ESK is positively skewed, and the IRT is symmetric or evenly skewed. What conclusions can you draw from this information about which club has the fastest runners? ESK has the fastest runners because it has the lowest value. The times are lowest in the ESK. Okay, so I hope this helps.